I want to talk in this video about a classic problem called the Josephus problem. Now, the original problem involves prisoners and murder and all sorts of horridness, but you can think instead of like a circle of children in the, when you're in the schoolyard and you have to select someone to be out of the circle with things like eeny, meeny, miny, mo, or one potato, two potato. So the idea is we go around the circle and we eliminate every nth person or every kth person, if we want to use k for the number of steps, the size of the step that we're going to make. Now I'm going to show you this in action, and then I'm going to talk you through some code that I've written to solve this problem. So first of all, let's run this code. And you can see what we've got is a text output showing the state of the circle. So you have to imagine this list, for example, people at the top here, is actually circular. So once you get to 5, you go back to the beginning, and you can see a representation of that in the console here. And the idea is, in this particular instance, I've set n equal to 5, so there's 5 people in the circle, and k is equal to 3, so we're going to eliminate every third person. So the first person we eliminate is 3, and you can see here, after doing that, the state of the list and the visual representation show the third person missing. And then we press a key, and you can see that the next person to be deleted is 1, because we were at 3, and then we moved forward 3, so we went 4, 5, and then we wrapped around back to 1. So you get the representation here. And so on and so forth. And the idea of the original problem is to be the last one standing. So in this particular instance, with n equals 5 and k equals 3, the last one standing is 5. So you have not, if the rules of the game meant that the last one standing was the one to survive or the one to win, then with these particular numbers, you have not won. And that would be an interesting thing to explore. So beyond the kind of coding aspects of this problem, it's a very interesting mathematical problem with all sorts of different angles you can explore. One simple one would be to work out, what values of n and k guarantee that you're going to be the last one standing. Okay, so let's look at the code. There's a function which I've provided, and I really do not expect you to write this yourself, but it's very useful for displaying the circle in a text format, as we just saw. So you get that kind of arrangement around a circle, and it uses all sorts of very interesting mathematics, which if you're into that kind of thing, I would encourage you to write this function yourself, but it's not easy and it's not the point of this video. So we're going to provide that for you. I'll leave a link in the description. So the interesting bit, or the bit that I would expect you to do yourself, is this bit down here. Now, if you want to stop the video and have a go now, what you can do is you can go and get the function from the paste bin, and I'll put a version there without the rest of the solution. I'll also put a version with the solution. So go and get the function if you want, and then try and write your own implementation, basically bearing in mind what I've just shown you about how it works without looking too much at what I've highlighted now on the screen, because that's basically what you're going to be copying or creating for yourself. So pause the video and do that now if that's something that you want to do, which of course I encourage. So if you're ready to look at a solution to this, I want to point out that the solution I provided is a more kind of intuitive one. Many of the solutions you'll find to this problem involve modifying the length of the list as you go along, so deleting the items in certain positions as you go along, and that then modifies the length of the list, which if you do in a loop can be very, very confusing and tricky. And I would say that's a much more advanced problem than the one I've done here, where we simply replace the integer in the list with a pound sign or hashtag. So this is what I've done. I've given us values for n and k, and of course you're going to be playing with those, changing them as you go along. Position to delete, that's going to change, but it's originally set to k. So the first one we're going to change is the kth from the original position, so the kth one in, which is going to be 3. Then we create our list. On line 32, you might notice I'm using these underscores because I don't actually need the variable name, and that's a very Pythonic way of doing things. And this whole structure is called a list comprehension, which are well worth looking into again if you're interested in Python programming in general. Then I've done the first bit of output outside of my loop, just to set things up, so you can see we display the people array as it is, and then a blank line, and then we call this function to display that in a circle. And then we have a while true loop, which some people really don't like. I think they're very useful in certain situations. Certainly very related to event-driven programming, so I see no problem with them myself. So yeah, we print a message so we can kind of keep track of what's going on. And there's this real issue with Python and many programming languages, probably most of them, where we have zero-based indexing. So I have to do all this offsetting all the time. So pos to delete -1, okay, because we have this zero-based indexing. So the number 1 index in the people list is actually the second item in that list. So we have to keep doing that offset. And that can take quite a lot of brain power to kind of wrap your head around to begin with if you're writing this yourself. Obviously, if you see someone else's code, you're like, yeah, of course it needs to be that. But if you're doing it yourself, which is what I encourage, then that might take quite a lot of thinking about to get that right. And then, we're giving the user constant feedback about what's going on. And then we're having a pause so we can press a key to continue at each stage so we can kind of study the output. So this is my solution. Anything else I need to describe about that? I mean, the function call on line 42, that's fairly clear. Obviously, we have to increase the position to delete, and then that gets wrapped around by this modulo. So the key to this whole thing really is the modulo operator, mod n in this case. N is the length of the list. So I would really encourage you, if you're not familiar with the modulo operator, to use it here, understand it in this context, and then go and study it in lots of other contexts as well, because it's such an important tool in programming in general. Let's just have a look at some different values for n and k. If we have 10 people in our circle and we do every second person, you can probably predict what that's going to look like. So if I run that with F5, this is idle in dark mode, by the way. So this is a really good function to get these numbers in a circle. I'm very pleased with that function. But you can see the first round, we're going to delete the second person, and then it's going to be the fourth person, and then it's going to be the sixth. And as you can probably predict, we're going to get a situation where, after a few rounds, we've still got the same people down, and other people, or the odd-numbered people, are actually remaining in the circle. And you're going to get very different results for different numbers. And as I say, that's part of the investigation here, is to find numbers which give different outcomes. For example, I want to be the last one standing. Okay, so that was the Josephus problem, an intuitive implementation that doesn't involve modifying the list within a loop. I hope you found it useful and interesting. Please like and subscribe, and I'll see you in the next video.